Today we're going to start our challenge number 12 and 13 today. So that would be our hard coding issue part 2 and input validation issues part 3. So let's start with the first one, which is our hard coded, and over here we're going to take our Linux machine, JEDEX. So we're going to use for reverse engineering part. So JEDEX GUI diva.apk. So we can try to look the source code review over here to penetrate our skills and finding some loopholes over here. So as per we were, we're going to do our hard-coded issue, which that was be part 2 over here. And let's have a look over here also. So ADB connect with IP address 126. Okay, so I guess I have missed the IP address. The IP address was it was 123. So pardon me. So let's go over here again. Let's clear it out and the 123. So we can see we have connected with here. So let's do shell. Okay, I forget that I have to write ADB shell. So we are over there. We are on board. So today we're gonna start with the hard-coded issue part 2. So we have done the part 1, which was clear text API keys on the source code that can be easily handled. But today we're gonna start with the hard-coding issue part 2. And over here, according to the OWASP top 10 of the mobile application, you can see top 10 critical vulnerabilities, which is given over here. Insecure communication, insecure data storage, improper platform uses, insecure authentication. So I will say this hard-coded issue is vulnerability of your insecure data storage. And over here we can see we have client code quality, which is your poor code. You can say that this was a security decisions via untrusted input, one of the lesser used categories. This would be a catch all the code level implementation programs in the mobile client. So it will be our automation part. Code tampering is also you're patching the binary codes or reading the source code over there. Reverse engineering, extraneous functionality. Often developers include hidden backdoors, functionality, or other internal development security control, and are intended to release into the production environment. So our major concern would be over here to simply check the insecure data storage. And the new categories in a combination of M2 and M4. For the mobile of the tab 10 2014, it covers insecure data storage and uninitiated data leakage. Uninitiated data leakage on the source code part. And that was M4 also, which is your insecure authentication. So if you talk about the authentication layer, it's all about getting the access to the server side. Failing to identify the user at all when the should be required. Failure to maintain the user identity when it's required. Weakness in session management. So we have to look for all the things one by one in our upcoming sessions. So the major perspective over here, we're going to check all the codes and revisions over here. So we have our target. So find out what is hard-coded and where. Developers sometimes will hard-code the sensitive information for easy. So over here they have mentioned you have to find out the vendor keys of the sensitive information. So before that, let's have a look on the HackerOne report. Hardcode issue, mobile application, HackerOne. So over here you can see on the screen it was a report from the 2017 and it was on the Zomato part. So authorization condition for one of the development environment when hard-coded in our Android app. We change it soon after it's reported. So they have given a proper validation part. After decompiling the Zomato app, I found HTTP credentials in the app. The sorted happened on the accident since I have looking for the new endpoints of the API intent after looking for credentials. After the credentials, I didn't know them, the domain they have belongs to 503. Error. Doing a subdomain brute force discovered a subdomain where the credentials would expose a clone of the main part. So modify it down, it's been 5 minutes and login. So you can try to look there. Hardware condition in Android applications is given. The mobile applications contain a URL that include credentials for the third party by a capture API keys. So they didn't disclose the information or anything related to that. So let's have a look over here. Hard-coded API keys or Node VPN applications. So some of the applications keys can be given over here. Google API keys, just like with this one. So impact data storage of sensitive informations. So there are further things can be happen over there if you simply check for. Or we can do, instead of the hacker one, there are lots of time we can read about the medium. So what we have over here, which are the OWASP top 10, critical vulnerabilities, weak server-side control, insecure data storage. It's an old one. Hint, hey hint, help me to getting out this hardcoded string help. Okay, you have to log in over there. So over here, let's try have a look what we can do with the path to get the data from the server side. That can help us for the relevant part. So over here, you can see that hardcoded issue using GNI, which is your Java native interface. So what is the use of GNI first of all? Let's suppose we have to read those things first. So GNI, which is your JavaScript native language. So Java native interface is a programming framework that enables Java coding running. GVM is to be interact with other libraries also. The libraries, which is your dependencies, which is used for functionality. So other programming language could be your C, C++ can be interact with the Java code also in the GNI part. So our major objective of the GNI to understand what is the main objective of GNI, because whenever the application is running, the GNI is always there. So if you look over here, the GNI native interface, which is your framework that allows you to code Java code to call native applications and libraries within the such languages such as C, C++, and objective of C. If you have any other choices besides GNI, do other things. Dealing with the native libraries is a huge source of a pain. A source code review is important when supporting to the Java applications. But said, sometimes you have just to avoid using GNI. So the main objective of the GNI is to tell you about whenever the application is running, we have the GNI is always in the backend server. So over here we have hard coding. So what is exactly hard coding is? So sometimes developers forget they have pasted any credentials or any password on the source code, which is, you can say, unreliable or which cannot be controlled. So you can see hard coding in a computer programs or text markup to hard code, less frequently hard code is used to explain rather than a symbolic name or something that can be likely to change in data time. Such coding is sometimes known as hard-coded. Now it's just a more difficult to change in data becomes necessary because we forget. Some of the developers, they forget to erase those data because they don't know where the data has been stored. So the hard-coded issue is basically your credentials which is stored on the server side and we can get access over there. So over here you can see the main objective is to read the source code. So that's why if you want to do the Java application pen testing part, so I will say start learning Java. At least you should read about the source code, what exactly the source code mean over there. So clicking on the hardcode issue part 2 in your application, the goal of this challenge is to find the vendor key and submit it to the application part. You can see they have given the following code: private diva JNI, which is your Java native interface, public void access. They haven't given a proper class. You can see they have given the edit text, find view, DJ any access. They have make text, creating a file, grant access to see the return card, access denied, and over here protected void on create bundle parameter, and they have given a bundle parameter. But just leave this one. They have just making a class which is called diva GNI file, diva GNI. So they have making a class, a file over there on the server side. So over here, if you looking at the above code of the hardcoded issue classes, it appears that the activity is creating an object of the diva GNI class when it's loaded. Exploring for the other reveals that is called diva GNI.class. For example, you can see public class diva GNI, private static final string, which is diva GNI, a load library. So as we have mentioned, that diva GNI is interact with the libraries also. So diva.class, from the above code, it's clear that the native library called diva GNI is loaded. Libraries can come from the APK files. So they are usually located in the lib directory. So you can see they have given a proper file that you have to go over there on the server side on the application part. So sometimes some of the sensitive information can be revealed on the server side also. So what are we going to do? We are on the server. So we're going to go to the data, jaka.asem. Yes, jaka.asem. Yes. So that's too clear. And over here, I can see we have app view, cache file, data, and lib, which is our library. So let's go to the lib directory, because JNI is basically used for interacting with the libraries files. And over here, I can see this is the file which is over here on the lib djavani.so file. So as per the source code, you can see also over here that they are making files over here on the server side that can be used for the further stage. So there are various things can be happen over there one by one to be complete. So over here, this is an SO file, share object file. Share object file, if you search for the SO files on the Google, .so files. So over here, SO files is compiled library files. It stands for share object, and it's analogous for a Windows DLL files. Files will place this user library and user library files. Sometimes place similar when they install. So how you can open this file? You can open this files on your binary text editor. If you want to open as shared library files, you have to open like another binary files with a hex editor. There are several hex editors in these standards repositories such as gex. Why it's saying this one? Because if you use to open this file on the cat file, you will see something like this. A lot of junk words. So our major objective, we have to use this file to get a proper hexadecimal values on the server side that can reveal us sensitive information. And if you look for other data like how debug mobile application requests and their APIs, using Azure Key Vault for mobile applications, and how to choose the right mobile applications for your part. They have given lots of further documentation that you can use over here. So let's have a look on this one. So our main objective is to find some hard-coded issues on the server side that could be on plain text. So if I'm using cat command, so it's basically loading all the hexadecimal values. So what I'm going to do, I'm going to use a command called string command. Through the string command, we can simply get all the files in a proper manner way. We just have to fetch this, you can say the strings on the application that can be used for the later purpose. So our main concern would be to check all the things over here, and we have to analyze those things. So we have lib diva.so file, finish file, see, scrappy, string copy, JNI onload. So these are some words on the server side. Dot dot. So as per the comparison, they have said you have to find the specific file on the server side that could be revealed of the sensitive information. Let's have a look. These all are strings, but we can see some hard-coded words. Hard-coded words are given over here to simply specify all the possibilities one by one. Our major objective is to find all the things. We can see they have given 3 hard-coded values. And these hard-coded values can be used in a different ways. So let's try any of this one. So let's try with a semicolon, asterisk, 2, percentage, and comma. So let's have access. Access denied, see you in hell. So we have a proper error on server side. So let's try over here. So see, they have also found all the words over here. So let's try with this one. OLST FGAD semicolon LH. And we can see access granted. See you on the other side. So the major objective of the hardcode issue is sometimes the library files, which is SO files, can be captures data or stored data sensitive information from the server side that could be lead us to hardcode issue vulnerability. And there are various other things can be happen over there. The most important thing is to understand the source code. We can also find a hardware issue in the source code with the following links. You can see I have given a link over here that you can use it for the further stages. This is a proper your source code. You can see sometimes if you enumerate the source code, you will see the data over there on the diva app source main JNI file, which is your JNI.c file. Just you have to decompile the file. The vendor key, which is hard coded over there. The most important thing is your static analysis. The static analysis play an important role on your application part that can be reveal a sensitive information on the server side. And there are various techniques can be happen over there one by one. So remember one thing, when you are simply using for information gathering part, you have to look all the possibilities that could be lead us to a different stage. So we have the proper the code they have given, the dot, and the vendor key. You have to simply specify the path. So it was on your Diva Android app source main. So I think we already have compiled these files on our local server. That was on the Diva. It was on your it's a meta informations, animations, colors. There are lots of things over here. Smiley directory, Android supports. So sometimes you have to look for the data over here. Some of the sensitive source code are available on the Google that can be lead us to different things can be happen over there. So our major objective of this course is to simply find the valuable data which is hidden on the source code. Because if you simply check each and every data we have find is useful on the source code data. So our major objective to check all the possibilities one by one. Include the GNI file, the string H, the Diva JNI. If you get any of the source code of any of the applications, that could be easy. That would be really helpful to identify the loopholes, because that will count as a white box pen testing part. So let's have a look on a different one. So the last and the least, we have, what do we have over here? We have input validation issue part 3, which is our last challenge. So this is a missile launch applications. DOS, which is your damn thing. Your object here is to find the code and then launch the missile, rather than it's to crash the application and find the root cause of the crash. Now they are saying that you have to specify the root crash of the application. Improper or input validation issue arise when the input is not filtered or validated before the using it. When developing components that takes input from the outside, always validate it. This is a classic information corruption vulnerability. If you can get a code execution, I would love to hear from you. So they have given enter the launch code for Bluetooth. So let's have a look over here. So input validation 3. So what do we have over here? They have given a launch and they have given time 10 seconds. They have given a proper time to be executed over there. So our major objective is to find all the possibilities one by one. That could be lead us to information part. So let's have a look over here. So they have given they specified a time period, launching in the time period of 10 seconds. Or 10 seconds of it, I don't know what could be the time over there. So input validation, let's have a look over here. DOS, which is your, over here, the last one is all about your DOS attack using memory corruption issue. So how the DOS attacks happen in the mobile application part? So it happens when the user input is given more than the allocated memory. Allocated memory. If I say in a room the only 10 persons can be entered in each time. If you put an 11th person, it could not be allowed. It will be overflow that room or the elevator. It overrides the memory fragmentations. The fragmentations which have a specific area to be consumed. Unexpected error occurs in the application, like your stack overflow and heap overflow. So today we're going to talk about a small descriptions of our stack overflow. Because heap overflow will be advanced because that contains DEP, which is your data execution prevention, and ASLR. So if we talk about a stack overflow, what is a stack overflow? A stack where the application contains the code which can be run in each and every time that we execute. A stack overflow is an undesirable condition in which a particular computer program tries to use more memory space than to call stack as available. In the programming, the stack is a buffer that stores requests and need to be handled. Stack stores a request. See. So whenever we are simply executing any command, so in the backend server, an application or request has been created. It is usually defined as the start of the program. So if you look over here, they have given a proper blog to be understand. So over here, buffer overflow exploit, Devil Kapil. So in this scenario, they are simply introduce you what is called that buffer overflow attack, and what could be the possibilities to check the memory applications part. So over here, you can see they have given a buffer overflow. Here they are using GTC. What is the tutorials? I assume the people have a basic intermediate knowledge of C. That could be like familiar to GCC, which is GCC compiler. So they have given a proper file over here. Or if you want to read about more about the buffer overflow, you can write buffer overflow because I read all the things over here. You can see it's basically run from low memory to high memory, and they contain some ESP, EBP, and high. So ESP is your stack memory, EBP is your base memory. In EBP, the the main function, the main call is over there in the stack, ESP. The EBP is the base memory where the application has been executed, and we have a return address also. So if you look over here, what is a stack? A stack is a limited access of data structure where it contains the applications to be executed. Elements can be added and removed from the stack only on the top. It works like LIFO, last in, first out. So over here, they have given two operators, which is your push and pop. Push, add a item to the top of the stack, and pop is to basically remove the item from the top of the stack. See, push, add an item to the top of the stack, and pop removes an item from the top of the stack. So how the memory application looks like, it's basically have a text file, a data, and a heap, and a stack. So it works like your low memory to high memory. So what exactly those things? Text memory contains program code to be executed, the actual code. Data contains global information about the program. Stack contains the function parameter, return address, and the local variables of the function to be stored. It's LIFO. It's grow downward in the memory from high memory address to the low memory. And heap holds all the dynamically allocated memory. Whenever we use malloc, you get memory dynamically is located on the heap flow. So our main function is not heap. Our main function is stack, where the function parameter is called. So they have given some registers over here, same CPU register, which is your EIP, instructor pointer, ESP, your stack pointer, EBP is your base pointer. So we just need these three. We don't have to read of this these all things. So for stack, for the stack-based buffer overflow, we all focus on EBP, EIP, and ESP. EBP points on higher memory address on the bottom of the stack, and ESP points on the top of the stack of the lower memory. And EIP holds the address for the next instruction to be executed. It's a scheduler. Our prime focus on EIP register since we need to hijack execution flow. If you control the EIP, it means you can simply perform a buffer overflow attack on the server side. So the three things should be important. EBP, EIP, and ESP are the important things can be happened over there. So they have given a proper function, a stack pointer, memory layout. So what we're going to do over here, we can try to execute the commands. So this would be a proper scenario. The function stack frame, the EBP, the return address, and the main stack frame. So let's have a look over here. So we're going to perform a buffer overflow attack over here on the application. So they have given in this field, as we can see, the application has given an error after entering the multiple A's. So we're going to put some buffer memory over here to crash the application. So let's have a look. So let's put some A's over here. So access denied. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Access denied means capability and 20 characters can be input over there. Let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 30 characters. Again, the 30 characters can be input. Let's try again 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can see the application has a crash on the 40 capital A's. Unfortunately, Diva has been stopped. Why? Because the application has a proper layout, which is your 20 after 30 characters or the 39 characters. Let's try 39 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 38, 39. So let's try with this one. It's crashed. In 39, it also crashed. So what I'm going to do, we're going to check the memory layout. The memory layout that can be help us to identify where the application has been crashed. So for this scenario, let's have a look on the Google also. So I'm going to look for buffer overflow, mobile application, medium. A data buffer is just a buffer is the region of the physical memory used to temporarily store data while it's being moved from one place to another. When you download a movie from the internet, it would be loaded about 5 minutes, or it should be moved from a buffer, which the memory playback. Buffer means you have to simply send data in a specific period of time. And what is buffer overflow over here? A buffer overflow of overflow or RAM occurs when the volume of the data exceed the storage capacity of the memory buffer and overrides adjustment memory location. So over here, what I'm going to do, we're going to try the buffer overflow, but so I'm going to use ADB. Let's clear it out. So I'm going to use ADB logcat. So we know about the logcat. We're going to use it for analyzing the part. Yeah. So ADB logcat is running. So let's try the buffer overflow again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's try 40 capital A. So I can see again, unfortunately, Diva has been stopped. So what we're going to do over here, we're going to examine the log analysis. So let's have a look on the let's have a look on the logcat. So logcat is basically used for analyzing the memory layout. So we can see we have captured some memory layout over here. So if you look over here, this are some buffer memory over here, which is captured, which is your heap, you can say. Some of the buffer memory has been captured. So let's have a look. Yeah. So we can see they have given some buffer cannot be preserved, write block for 399 seconds, displayed Java.scene, feedback, dictionary informations, some security policies has been true, some coded has given over there. And over here we can see some EAX, ESAI. As I mentioned you, ESI, which is your stack pointer. And over here we can see it's 41. 41 in the sky value is your capital A's. And over here you can see the EIP, the instructor pointer, has been crashed with the capital A's because it exceeds the memory layout of the memory application. If you can control the EIP of any of the application, you can try to place a buffer memory or a malicious code over there, and you can execute arbitrary command execution. Our major objective of this machine was to find out the buffer overflow attack on the server side that will lead us to different things. Unrecognized of the data. As I mentioned, logcats are basically used to identify the behavior of the application that can be used for the further stages. So in this scenario, the application has been crashed. You can see over here, the application has been registered. The buffer memory has been registered with the capital A's. 41s are here, basically capital A's over here. So that's what will lead to a different attack. So through the Android ADB logcat, you can analyze the part of the memory that can be used for the further stages. And the application has been crashed over here normally, you can see. So in this scenario, the main objective of our goal was to identify the loopholes on the server side that will lead us to the exploiting problem. And the most important thing is to understand the buffer memory layout